Hello and welcome to Vandenberg Space Force Base on the central coast of California for the science briefing of the International Surface Water and Ocean Topography Mission, also known as SWOT. I'm Jasmine Hopkins with NASA Communications. SWOT will be the first satellite mission to observe nearly all the water on Earth's surface. This will help scientists understand how water moves worldwide and give us new insight into climate change. SWOT is an international collaboration between NASA and the French space agency CNES, with contributions from the UK and Canadian space agencies as well. This mission will lift off aboard a SpaceX Falcon 9 rocket this Thursday, that's December 15th at 3:46 a.m. Pacific. And this will mark the 101st mission managed by NASA's Launch Services Program based at Kennedy Space Center. Joining us today is a distinguished panel of guests ready to uncover the science behind SWOT. Starting on my left, we have Kate Calvin, Chief Scientist and Senior Climate Advisor for NASA. Selma Churchali, Earth Observation Program Manager from CNES. Nadia Vinogradova-Schiffer, SWOT Program Scientist for NASA. Tamlin Pavelski, SWOT Hydrology Science Lead from the University of North Carolina. And finally, Benjamin Hamlington, Research Scientist for the Sea Level and Ice Group at NASA's Jet Propulsion Laboratory. We are so glad to have this panel of experts with us today, and they'll be answering questions from media here in the room and over the phone. We also invite the public to join the conversation online using hashtag AskNASA. But before we get into your questions, we're going to give each of them a moment to introduce themselves and their role in the mission. And Kate, we'll start with you.
Yeah, thank you, Jasmine. NASA has a long history of studying our home planet. So if you cue my first animation, this is going to show you the current Earth-observing fleet. We have more than 24 Earth-observing satellites and instruments in orbit, including several on the International Space Station. We have more than 60 years of satellite observations. Many of those observations and satellite missions are in partnership with other U.S. government agencies or international partners, like SWOT, which is in partnership with CNES, the French space agency, with contributions from the UK and Canadian space agencies. And SWOT is continuing our legacy of partnership. When we're looking at Earth from space, we've been observing the Earth for decades. We can see both the state of it now, as well as how it's changed over time. And we're thinking about where NASA's going forward in Earth science. It's continuing to innovate and do new observations, as well as to work on providing that information to the public as stakeholders and users to ensure that they have actionable information as they're going forward. And SWOT is a part of both of that. SWOT is one of the missions that's going to help us lay the foundation for going forward, a new generation of Earth observing and remote sensing missions, both because of the type of information it provides, but also the diversity of people that we're expecting to be able to use that information. So it is part of a future set of Earth observing satellites. Another area we're working towards is the Earth System Observatory, which is the next set of missions that will provide a more holistic picture of the Earth. In terms of accessibility of information, we're going to be reaching a new set of users with SWOT, and we're also working within NASA to provide that information and make it more accessible through things like the Earth Information Center. So just a little bit about SWOT before I hand it over to my other colleagues on this panel. So it is about surface water and ocean. So it's on the surface waters. It'll provide the first global survey of water running through rivers and lakes. It'll help us understand where water is, where it's coming from, and where it's going. For oceans, it's going to allow us to observe ocean features with higher resolution. Oceans absorb a lot of carbon and heat, and this will give us a better understanding of those processes and help us improve both our understanding of the oceans as well as our projections into the future. And with that, I'll turn it back to Jasmine.
Thank you so much, Kate, for getting us kicked off on our opening remarks. A lot of great background information there. Next, let's turn it over to Selma Churchali.
Thank you, Jasmine. I'm really delighted and very pleased to be here with you today. As the Earth Observation Program Manager and the former SWOT program, this is with a deep emotion that we are merely now less than 2 days before the launch SWOT. And the SWOT launch today is really timely correlated to the anniversary of more than 3 decades of excellent cooperation between NASA and CNES, marking the anniversary of the launch of the first Pathfinder mission called Topex Poseidon, dedicated to ocean altimetry mission. Since that time, the international cooperation has been extended to many other space agencies, operational ones, EUMETSAT, NOAA, and the European Union Copernicus program has decided to implement a new generation of Copernicus Sentinel-6 microfraglich, which has taken over JSON-3 as the new satellite altimetry reference missions. Could you please put the slides? If NASA and CNES have decided to make this mission happen, extended to UK Space Agency and Canadian Space Agency, it really thanks to their trust to collectively have the capability to handle such innovations and challenges. Few days ago, we were on the Committee on Earth Observation Satellite plenary meeting in France in Biarritz, where we had the opportunity to meet with the UK Space Agency leader, CSA leader, and NASA and CNES, with the picture you have just in front of you. This is a great celebration marking this excellent cooperation, and what a better present than the SWOT within this anniversary of 30 years of cooperation. Of course, within the global warming, there is a huge impact today we know on water cycle. Accelerating this water cycle by putting some drought in some parts of the world and floods in other parts. And we are reaching our knowledge within the Earth cycle with some limits. And we know there are many of the compartments of this water cycle to be understood. And that's why SWOT will be really a pathfinder mission providing new measurements, a new era, by having a first global inventory of the surface water bodies, by providing heights of the surface water, slopes, and delivering what we call the Graal of hydrologists, which is discharge. And in the meantime, we will have also an important fine picture of the stock water within the lakes, reservoirs, and wetlands. We are speaking about revolution in hydrology, but in the meantime, we will for the first time address key processes within the ocean. Those key processes are totally unknown today. The scientists made an important hypothesis that with those fine-scale processes, currents, eddies, filaments, SWOT will provide those measurements in order to understand those processes which play a critical role in the global circulation ocean and related to climate change. And this is really important provision from, of course, the SWOT mission. Next slide, please. Since the beginning of the program and the Memorandum of Understanding, which was signed between NASA and CNES, the science community was initially involved from the beginning. First of all, for establishing the science requirement. Then after, with the science definition team and the science team, they play a key role in order to refine those requirements and the specifications, taking into account the constraints from the technical point of view and budgetary ones. And the way that we used to work closely between the projects and the science community was built through and over these 3 decades. And this is really an important aspect of the success of the past and current missions, and of course of the upcoming one, the SWOT missions. And the next slide, please. We had many, many meetings with the science team. And we now have more than 17 countries involved within the preparation of SWOT. Why 17 countries? Because with this unprecedented measurements, new ones, we need to make calibration and validation of those measurements. And across the world, there are many teams already in starting block in order to check those measurements and to validate them. Next slide, please. NASA and CNES worked jointly to prepare the call towards the science community in order to decide, to assess, and to, of course, identify the key proposals that would make really advances in science and in the projects. And here you have some of the meetings we had in France in 2015. Next, please. And the last one, before the COVID crisis, was held in Bordeaux in 2019 with one of the key NASA science program, Eric Lindstrom, who has now retired, and we have now Nadia next to me, who has become the new ocean science program. Of course, beside the science perspective and the awaited advances that is expected from SWOT mission, since the beginning, we initiated the SWOT early adopter programs. On French side, we called that the SWOT downstream preparatory program. The aim of the program is to enlarge beyond the science community to all users around the world, and of course, within the water agencies, within the, of course, navigation agencies, many users, in order to allow them to prepare the handling those SWOT data within their premises and within their Earth system in order to deliver operational services. We are speaking about prediction of floods, and we are waiting, of course, an important improvement of those key models for prediction flows, but also for ocean circulation at the key scales. So we are really waiting all in a very exciting manner this marvelous and Pathfinder SWOT mission, and looking forward to the success of the SWOT launch. Thank you, Jasmine, back to you.
Selma, thank you so much. Great opening remarks and also a good highlight to our international collaboration. Next, we're going to turn it over to Nadia Vinogradova-Schiffer.
Thank you, Jasmine, and thank you, Selma, reminding of NASA CNES strong altimetry marriage that going on a 4th decade. It's an open marriage. We're making new friends along the way with Canada and UK with the SWOT. And as Selma already mentioned, SWOT is a Pathfinder mission. And what it means is that there are many firsts with the SWOT satellite mission. We're testing new technology, new approaches to measure Earth water, height, volume, its dynamics. We are forging a new community of scientists and users. We are changing the culture, the business of doing science, making critical and complex Earth information more accessible, more inclusive, more actionable, while still maintaining the highest standards of scientific integrity of our information that both NASA and CNES are known for. So with that many firsts and all eyes on SWOT, it's truly a pivotal moment for our space science industry. A moment that will define future standards in Earth observing, particularly satellite altimetry, in order to define, are we truly maximizing with these new technologies and new approaches, are we maximizing our return on investments, our scientific and societal return on investments, and observing and predicting Earth water is a worthy investment, as we as humanity depend on Earth water to survive and prosper. Let's just take a quick look at how water moves, a little bit Earth science one-on-one. If you don't mind, just the first image. What we're looking here is the precipitable water and how the water moves from ocean to land. We know that oceans is the ultimate source of all moisture and water on Earth. Think of oceans, those huge warehouses that supply moisture and water to land that we rely in as our drinking water, agriculture, and industry. And this SWOT, a global look, on both ocean and land water. It gives you truly look at the supply and demand chain in order for us to truly look at the earth water as a holistic process, and that enables a better predictive capability if you truly observe the supply demand chain. Just think of it as if you come to your local grocery store and you want to buy some fruits or vegetables and the shelves are empty. Right? I mean, at that point, it's kind of too late to prepare. But if you have information that your farmer, your supplier of your produce experience some disruption, either shortage or excessive supply, then you have more time to prepare those disruption when you come to the local grocery store. So the same with earth water. If you want to prepare for the upcoming flood or a deficit of land water, you do look at your supply, your farmer, the ocean where the moisture originates. So that's, of course, a unique aspect of the mission and a welcome one. Another breakthrough with the SWOT technology, of course, is that we're going to look at earth water at a very high resolution and clarity like never before. I call it a SWOT goggles. So it's a 10x improvement in clarity and resolution of earth water. Let's see what it means for the ocean, if you don't mind. On the next animation, what we're looking here is ocean movement. The red colors represent warmer oceans, and the blue colors are cooler oceans. And what we see here is essentially that ocean is a turbulent flow. And ocean turbulence and eddies are constantly on the move, and they are busy and effective engines transporting a large amount of kinetic energy, heat, mass, salt, nutrients, carbon, plastic, pollution, you name it. So this constant movement that is initiated by those active players in the climate system are what keeps our Earth system functioning or dysfunctioning, as we already see in our measurements. So when we, in the business of making better prediction of the Earth system, of the global warming, we rely on the ocean to take it for the Team Earth, and absorb most of the global ocean, global warming within the ocean. And that, think about it, that half of the vertical transport of this heat absorption from the surface to the deep ocean is done by turbulence. Half. The turbulence matters. Perhaps turbulence is that missing climate puzzle piece that we've never observed, and that would help us solve this climate prediction better. Enter SWOT. A very timely entrance, an entrance as we look at our changing water on planet Earth just in front of our eyes. So we're ready for you, SWOT. And go SWOT, yeah? Very excited. Back to you, Jasmine.
Thank you, Nadia. I love your energy. Yes, we are very excited for SWOT. Next, we're going to hear from Tamlin Pavelski.
All right, thanks so much, Jasmine. So as you've heard from some of our other speakers, we're really going to see this big new capability with SWOT to see our rivers and lakes in high definition. And that's immensely exciting. So right now with satellite imagery, we can see pretty well where rivers and lakes are located, right? We can see their area pretty well, but we don't do nearly so well in terms of our ability to see the height of the water in them. And really the key advance for SWOT in terms of surface water hydrology is that we're going to be able to simultaneously measure the extent of water and the height of water. And adding that new dimension is critical because it allows us to think about things in terms of volumes and changes in volumes over time, right? So all of us learned about the water cycle at some point in elementary school or middle school. And, we heard a little bit about it from Nadia already, thinking about the transport of moisture from oceans via the atmosphere onto the land surface. And for the entire water cycle, if we really want to understand it in ways that are important for us, we need to be able to think about it not just conceptually, but in terms of volumes. How much water is there and how is it flowing from place to place? And SWOT is going to allow us to do that. For lakes, we'll be able to see how the volume of lakes and reservoirs increases and decreases over time. And for rivers, we're going to be able to see how essentially we'll be able to track the volume of water flowing through rivers from space, which is just really exciting and frankly pretty unprecedented. So what are we actually going to see with SWOT? Let's get down to brass tacks here. For lakes, we expect to see lakes larger than about 15 acres, so that's 250 meters by 250 meters. And we expect to see almost all of the world's rivers wider than about 330 feet, or about 100 meters. So let's take each one of these individually, and let's start with lakes. Could I have my first slide, please? So right now, if I went out and wanted to get data on changes in water level or volume in some of the Earth's lakes, I could probably get pretty good on-the-ground data for maybe a few thousand of them scattered over the world. SWOT is going to observe millions of lakes. So we're going up by orders of magnitude in terms of our capability to track water through lakes and reservoirs. And this matters a lot, whether you're thinking about a really ecologically vulnerable lake like the mountain lake that we have up here in this image, or if you're thinking about a reservoir in a rural part of India where people depend on that water for irrigating their crops. SWOT is going to provide the free and open data that everyone needs in order to be able to track these really important resources. Okay, so what about rivers? Could I have the next image, please? So what you're looking at here is a map of all of the rivers that we plan to observe with SWOT. There's about 2.1 million kilometers of rivers worldwide. And for all of these rivers, you know, we plan to be able to observe that volume of water moving down them, which is really impressive. So right now, when we try to observe rivers around the world, we use a network of sort of on-the-ground gauges. And those gauges are expensive to maintain and install, and they're very unevenly distributed around the world. Now, they can do things that SWOT can't, right? Like they can provide data every 15 minutes, which is great. But SWOT can also do some things that they can't. So, for example, SWOT will observe the entire length of a river rather than just what's going on at a single point, which is really cool and really different. So let's look at one specific example here of where SWOT might make a difference for rivers. Could we have the next image, please? So what we're looking at here are the rivers that we expect SWOT to observe in the Congo River Basin. So the Congo, it's the second largest river in the world. About 75 million people live in the Congo River Basin, and yet we actually have good on-the-ground observations of flow through the Congo River at a handful of places in this entire area. And with SWOT, we're going to be able to observe all of the rivers that you see up on the screen here, and it's going to really help us do a better job of serving people who live in this basin. And that's particularly important because the UN has identified the Congo Basin as a basin that's particularly vulnerable to the impacts of climate change. So if we put all of this together, SWOT is really going to allow us to understand sort of how water volume changes in our rivers and lakes worldwide. And that's a new and exciting thing. So I've been working for the last 20 years or more on trying to use satellite data to understand Earth's surface water. And we're constantly having to come up with ways of using data from satellites that weren't designed for what we want to do, right? We're repurposing other people's data. And we've been able to do cool things with that. But SWOT is the first satellite that's specifically designed to study rivers and lakes. And it's going to be a real game changer. I'm so excited about it. Back to you, Jasmine.
Thank you, Tamlin. We really appreciate you shedding light on so many different bodies of water. We have one more panelist to hear from. You've been waiting very patiently, so let's throw it over to Benjamin Hamlington.
Thanks, Jasmine, and thanks to the other speakers. So I want to focus in a little bit more on some of the societal benefits and applications of the SWOT data. We've heard that SWOT is going to provide measurements of nearly all surface water here on Earth. We're going to have measurements over the land, over the ocean, but also where land and ocean meet in this coastal interface, which is really critical. So many people around the world live along our coastlines. So SWOT's going to provide really relevant information for all these communities, all these people living in these different places, and allow us to make measurements that will ultimately improve our lives and livelihoods. So I want to walk through some of these examples, starting with the land first. So as Tamlin and others have said, SWOT is going to give us this really new look at the lakes, rivers, and reservoirs across the globe. So on these global scales, we're going to be able to see things that we just could not see before. We're going to be able to track the movement of water around the earth between ocean and land, be able to make some of these connections and really understand where water is at any given time. So this is really critical because we know with climate change that the Earth's water cycle is accelerating. What this means is that some locations have too much water, others don't have enough. We're seeing more extreme droughts, more extreme floods. Precipitation patterns are changing, becoming more volatile. So it's really important that we try to understand exactly what is happening using this SWOT data. So if we can pull up the first visual. So in this visual, we're showing the Connecticut River, which flows through several states in the northeast United States. SWOT is flying over with its swath measurement, measuring the full extent of this river as Tamlin referred to. These red colors here are higher water levels, so SWOT is measuring water levels, not just the extent of the river as it changes over time. But SWOT's going to continue to make these measurements, track the changes that are occurring in rivers like the Connecticut River, and provide very important information for those that rely upon it. So what does this mean? So with the SWOT data, we can give really important information to a wide variety of stakeholders. Really anyone that cares about water should be concerned about what SWOT's going to provide. We have water resource managers. We have emergency preparedness agencies, civil engineers. For those of you at home who are maybe concerned about access to water or flooding and drought, we'll be able to better predict the occurrences of those things with the SWOT data. So it's really going to provide rich information that impacts all of us. And really importantly, it's going to measure these on global scales, right? So in the US, maybe there's some areas that we monitor really well with in situ observations, but on global scales, some of these rivers, lakes are very difficult to measure. SWOT's going to provide a solution to that. We'll be able to see those changes that are occurring on global scales, not just in specific locations. So shifting gears a little bit, focusing on the coastlines. So we know sea level is rising. Climate change is causing sea levels along the world's coastlines to go up. We know from other NASA satellites that the rate at which sea level is increasing itself. We can have our foot on the gas pedal in terms of the sea level rise that we're seeing. The impacts that are associated with the sea level rise are also expanding. They're worsening in severity. The impacts are getting worse. Here in California, where we are today, we see coastal erosion that's happening because of higher sea levels. In other parts of the country, of the U.S., we see greater storm surge associated with hurricanes. And all along the world's coastlines, we're seeing these impacts increase, flooding start to increase, and populations become threatened by sea level. Now, it may be surprising, but in some of these locations around the world, we really don't have a good understanding of what's happening at the coast. So the satellites we have now don't get us right up to the coast, a little bit offshore. We have tide gauge measurements, which are directly at the coast, but they're very sparse across the world's coastlines. There's big gaps between them. So again, it may be surprising, but we just don't know what's happening with coastal sea levels in a lot of these locations around the world. If we can pull up our next animation. The reason it's so important to understand these changes is because there's pretty fine scale sea level changes that are occurring in these coastal areas. This here is an image of the Mississippi Delta region. You can see SWOT flying over the ocean through that coastal interface and onto land. And it's going to provide rich information across all these different components of that coastal zone. So we're going to be able to provide this information to those that need it most, these coastal communities that are already planning for and adapting to the sea level rise and coastal impacts that are occurring. There's a wide range of stakeholders that are impacted by sea level rise. National security is an issue certainly that comes up. Our military has a lot of infrastructure in these coastal regions. Being able to provide this information to the military and other coastal communities will allow them to better plan for what's happening and account for those changes going forward into the future. So what is being done to ensure this data is actually useful? What are we doing to make sure that this data can be used in all these different applications? So there's a couple things. So SWOT has this concept of open science. So we're making the data associated with SWOT available, publicly available. That's certainly important. But beyond that, we're also building tools to help people work with the data once it becomes available. Right? So we're not just providing the data, but encouraging people to use it, interact with it, and start to implement it within their applications. Additionally, we have something called the Early Adopters Program, which you've already heard about. It's an international program with early adopters, these different people who are working in, say, water resource management, working on the oceans, different applications. They come in and work with the SWOT team to really understand how to implement the SWOT data once it becomes available. It's an international team of these early adopters. We actually have a couple early adopters here that are going to be at launch with us tomorrow, one from India, one from Germany. So it's a really global scale effort to ensure that the SWOT data is ultimately useful. So just to wrap up, the SWOT data, it's going to measure surface water everywhere, right? We're going to have measurements both over land, over the ocean, but also that coastal interface. And it's going to provide such important information. It's going to be transformative in our ability to provide information that will ultimately improve the daily lives and livelihoods of almost everyone here on Earth. And with that, I'll hand it back to you, Jasmine.
Benjamin, and thank you to all of our panelists for those opening remarks. A great job from all of you. Now we're going to transition into the question and answer portion of today's briefing. For media here in the phone, we do have a microphone to pass you, so if you would like to ask a question, please just raise your hand and then you can state your name, your affiliation, and who you would like to answer your question. For media on the phone, please press *1 if you would like to enter the question queue. And if you're joining us online, feel free to use hashtag #AskNASA to ask a question here. And with that being said, we'll start in the room here with media. And if none would like to ask a question yet, we will go to our social media friends online.
The first question is from Instagram. Is there any kind of new tech that is being tested through SWOT?
New technology. Karen? Yeah.
Would you like to?
I'll start and then pass it to Salma. Yes, as one of the NASA's and CNES firsts, we're testing a new technology, which is a radar interferometer that operates at a Ka band portion of electromagnetic spectrum. We call it Karen. And this is a first in-flight demonstration for this new technologies to measure elevation of ocean and inland waters.
No, it's okay.
You answered it perfectly, Nadia.
Okay.
Very good. All right. We'll go to social media again.
How much more detail will we be able to see with SWOT than with current satellites or observation techniques, and why does that matter?
So I'm happy to talk especially about what's happening on land, right? So let's start by thinking about lakes, right? We have lakes dotting the world all over the place, right? And mostly we don't have an idea of what's going on in terms of how their water levels or the amount of water that is stored in them varies. And you can kind of think about each one of those lakes as like a little gauge that measures the water cycle, right? How much precipitation, how much evaporation, what's going on with the water cycle in that area. And so right now we have this sort of big blank canvas where mostly we're not using that information to understand our world. And once we have SWOT up there, we're going to be able to see that everywhere. And it's going to give us this much better picture of what's going on with the water cycle as a whole and with our water resources, right? How much water do we have available to irrigate our crops, to drink when we turn on the tap, for our ecosystems? So from a land perspective, that sort of extra resolution is going to be really critical. Maybe I'll pass it to Ben to talk a little bit about the ocean.
Or Selma, do you want to handle the ocean?
No, for the just to perhaps to complement Tamlin's answer on the detail, the question related to the detail, I think we have to notice that it's the first time that so finest measurement will be provided. As Tamlin explained during his intervention, we will have lakes with what we called spatial resolution, 250 meter per 250 meter. We have never provided such measurement before the SWOT mission. For the rivers, it's the same. The requirement is to reach all the river wider than 100 meter of the resolution with the goal of 50 meters. And there was really a huge preparatory work in order to prepare those database and to check if really SWOT measurement will cover all those rivers and lakes. And this is really a revolution as Tamlin mentioned, it is really the first mission dedicated to hydrology purpose. For ocean, regarding the long history and the current Nadir altimeter mission, we are with SWOT really making a breakthrough also for ocean, because we are aiming to provide fine scale observation 10 times better than the current technology, which is really, again, a first, what we called in French, a word première. So hopefully I respond to your question. Thank you.
I can add just maybe a little more detail on the coastal region as well. So I work a lot with communities, coastal communities, trying to prepare for sea level, provide them sea level projections to plan for the future. And the question always comes up, but what's happening where I am? Like what, right where I am here in this bay, in this very local area, what's happening here? And with the satellites we have now and the tide gauges, like I said, we really don't have great information there. But with SWOT, we're going to be able to get that, fill in those gaps, fill in those blind spots that we have now, and really start to refine our understanding of the sea level change that's happening in these coastal areas. So that finer resolution information that Tamlin and Selma talked about, it certainly extends into these coastal regions as well, which is going to be really important.
Thank you guys for teaming up to answer that question. We do have somebody on the phone, Ash Sonteng from Launchpad News.
Thanks for having me on. Question for the panel. How has the international collaboration helped the SWOT mission receive a greater reach into hydrology and oceanography research? And which of the scientific instruments or critical hardware has been provided by each of the international partners?
Thank you. Would you guys like to start in the middle, or do you need it repeated?
Yes, please, if you could repeat it.
Ash, would you be able to repeat your question?
How has international collaboration helped the SWOT mission achieve a greater reach into hydrology and oceanography research? And which scientific instruments or critical hardware has been provided by each of the international partners?
Thank you.
Yes, SWOT, as Selma already outlined, it's a truly collaborative endeavor. We have worked on it for about 20 years or so, and truly leaned on each other. This collaborative, this team spirit took us through multiple global crises over the past few years, from health crisis to political turmoils to you name it, to environmental crises. And so this international spirit, as I call it, like a World Cup kind of endeavor, that's really helped us to move through a major milestone. And in terms of engineering a collaboration, it was a collaborative effort as well, with both NASA and CNES providing key component and testing both in France and the US, and the observatory being ping pong back and forth between two continents. So it was we took collaboration on a new level, don't you think, Selma?
Yeah, I completely agree, of course. And regarding the question related to how we supported also the research community on both sides, from the beginning, we had always a joint calls towards the science community. We jointly assessed the French proposal, the US proposals. CNES was in charge also to assess and to select the international ones. And today, this collective and joint effort allow us to involve not only the 4 space agencies who are collaborating to develop the space segment, but more important, 17 countries are already involved in the preparation to handle those measurements and to calibrate them and validate them. Few days ago, I was chairing the CNES plenary meeting, and when we had from Nadia and Rosemary Moreau, who is the French Ocean PI, principal investigator of the mission, I was really very pleased to see that more than countries already involved are also have the willingness to join this international club in order to provide also their expertise, but also to benefit from those open data from the SWOT mission. So this is really a truly cooperative mission, of course, beyond NASA, CNES, CSA, and UKSA. Thank you.
Selma, Nadia, thank you so much for answering that question together. I believe we'll toss it back to social media.
And this question's for Kate. Kate, climate change is complex. How does knowing more about ocean circulation help us better understand climate change? And then how does that understanding impact our options on how to move forward?
Thank you for the question. So oceans play a really important role in climate change. They absorb a lot of the heat as well as a lot of the carbon. So when we put carbon dioxide emissions when we burn them through fossil fuels or other changes on the Earth's surface, some of that carbon goes into the ocean, some goes onto land, absorbed by trees, others stays in the atmosphere. And how the ocean circulates influences how much more carbon we can uptake. And there's similar processes related to heat. So as it gets warmer, the oceans are absorbing a lot of that heat. So better understanding the mixing process of the ocean will help us understand how much more heat and carbon we can uptake. And that's really important for understanding future climate change and how activities by humans influence future climate change.
Kate, thank you so much. I appreciate that. Seeing none in the room yet, again, we will go back to social media. Thank you.
And this one's from Russell on YouTube asks, will SWOT be able to see through forest canopy and vegetation for wetland water levels?
This is a really good question. And it is, there are a handful of questions that I am really excited to see what happens when SWOT launches, because I don't think we fully know the answer. And a lot of that is because wetlands are so complex, right? That term contains a vast array of different environments, from places like the Everglades, where you might have, grasses with water underneath, to places like the Amazon floodplain, where you have really dense forest canopies. If I had to guess, I would guess that SWOT might be able to tell us some really interesting things about what's going on in those sort of more grassland type areas or places where you have a little bit sparser vegetation. I think just because the wavelength that we're using is so short, it may be a little bit difficult for us to get really good data in places where we have really dense vegetation. But this really goes back to a lot of what Nadia was talking about, right? SWOT is a Pathfinder mission. And what that means is that when we put it up in space, we don't know all of its capabilities, right? And part of the joy of working on SWOT is getting to find out.
Thank you so much. Would you like to add, Selma?
Yeah, thank you. Just another perhaps insight on this important question. Within the early adopter programs and within the SWOT preparatory program, from the beginning, we are not considering SWOT as a standalone mission to address these key complex climate change questions and issues. And from the beginning, of course, within the CNES Earth Observation Program, also for NASA Earth Observation Program, we are considering the use of the SWOT measurement in conjunction with and complementary with other key observations in order to tackle those key questions in terms of what we call the physical measurements. And we have already today in orbit some European missions such as SMOS or SMAP on NASA JPL mission. From the beginning, they were not expected to provide, for example, the height of vegetation over tropical region. They were dedicated to other science objectives. But when we explored those new measurements, we could develop other key areas that were not completely expected from the initial missions. So my main message here is to say that SWOT measurement, yes, is an unprecedented measurement, but in the meantime, all the science community and all the users that we spoke about in the early adopter programs are preparing that in conjunction, in complementary with other measurements, but more important, tackling the complex climate change is also preparing the new generation of climate change modeling. We are speaking in France within the Copernicus Marine Service and Mercator. Since 2013, we are preparing the next high-resolution model which could assimilate and will assimilate those SWOT measurements in order to provide a better prediction, more than better 7 days. And this is the critical aspect also of the SWOT program, is to handle and to gather all the means, all the assets in order to make the better added value of those SWOT measurements.
Selma, thank you so much for that addition there. We do have another phone-in question. This is Lucy Odor with ASP.
Hi, can you hear me?
Yes.
Yeah. Thank you for doing this. Could you talk a little bit more about the scientific instruments on board? What are they exactly? Are they cameras, radars? Why these big two arms for the satellite? And yeah, how do these instruments compare with previous ones? Thank you.
Thank you, Lucy.
Do you want me to start? Yeah, so the heart of the SWOT system is the new radar interferometer, which we call Karen, as I explained already. There are two antennas, and one of them transmits an electromagnetic pulse, which bounce off the Earth's surface, being captured by both antennas. And those signals are a little bit out of sync, out of phase, what we call it. And that this phase difference combined with radar wavelength allows us to triangulate and compute the distance between the Earth's surface and the satellite, which we then translate to the height of the water. So, and we're doing it over this wide swath, like with two antennas doing it over the wide swath. I think Ben had a nice animation with a swath following, so over like 50 kilometers wide. So this is our first two-dimensional measurements of sea surface height or ocean height, right? Or water height, rather. Still, ocean physicist, yes. So water height, and that sets it apart from the traditional just downward-looking nadir altimeter, as what Selma referring earlier, that just look down and collect measurements of the water surface in a traditional, conventional way. We will have this nadir technology on a SWOT as well to complement Karen wide swath technology also, but so complementarity is another aspect of the SWOT observing system. Did I answer? Was it a two-part question, or that's enough?
I know that was good. That was on the instruments, I believe, so I think you covered it.
Just a few mistakes, and I edited it, but all right, we'll roll with that.
Yeah. Thank you so much, Nadia. I think we have time for about 2 or 3 more questions, so I will check back in with social media.
Another question from YouTube. Will moisture in the air affect the measurements?
Yes, and we have an app for it.
Yes.
Okay. The answer is yes, not
Yes.
Okay.
Yes.
The answer is yes, of course.
Yes.
And we have already some what we call within the classical nadial altimetry mission, and it is the case for the SWOT. We will have what we have a geophysical product that could benefit from those needed correction from the atmosphere impact on the measurement, of course. Ionospheric, troposphere, etc., of course.
Very good. Thank you, Nadia and Selma, again, for answering that together. Again, I'm looking around the room, but if no other are in the room, we'll go back to social media once more.
And this is the last one from social. When are you expecting the data to be available to the public, and how will they access it?
Perhaps
I can take it. Yes. So as we were saying, with SWOT, we are building an open science community, what we call it. So we're trying this experiment where we are releasing so-called pre-validated data sets and kind of inviting community to help NASA and CNES validate this new measurements together. So all hands on deck, and we're releasing this product in approximately nominal time frame fall 2023.
Yeah, this is an important rendezvous. I would like to say with the community. Today, all the data are aiming to be available by September 2023. But prior to this important milestone, there are many teams around the world to handle and to investigate those new measurements. This is really critical. And as I have the opportunity to speak about that, and at European level, we have also an important rendezvous with those CalVal measurements, SWOT measurements, because we are preparing the next generation of Copernicus Sentinel Topography mission. And of course, this new technology, as Nadia mentioned, is opening a new era, but in the meantime, a continuity. Continuity as Nadir is on board this mission, but also opportunities on new areas in climate change studies. And we have within the European Space Agency and the European Union an important rendezvous in beginning of 2024 after the reception of the calibrated and validated SWOT measurement. This is a really important rendezvous. Thank you.
Thank you. I think that was all the time we had for questions today, but you all did a fantastic job. I want to thank our panelists for joining us. Also, thank you to those of you who asked questions. We invite you to join us again right here on NASA TV for the pre-launch briefing. That will be at 10 a.m. Pacific time. And you can tune in as well to watch the launch broadcast. That is this Thursday, December 15th, with live coverage on NASA TV or nasa.gov/live, and that will begin at 3 a.m. Pacific. For more information on SWOT science, you can go to swot.jpl.nasa.gov. And you can also follow along with the mission at blogs.nasa.gov/SWOT. We thank you all again here in the room and to our panelists for joining us today. And until next time, go SWOT.
Go SWOT. Go SWOT.